A study found that showing fake, incorrect AI predictions to physicians made their performance significantly worse. Another study found that showing correct AI predictions without a convincing interface yielded no change in their performance. How to maximize assistance while minimizing errors. Models can convey their predictions graphically, and physicians can use their knowledge to interpret them. If physicians can see the features being used, then they can determine for themselves if the model is correct or not. We performed a reader study to evaluate if counterfactual explanations can prevent false positive predictions. We asked two radiologists to evaluate how confident they were in a model's prediction. 240 chest x-rays were selected from the NIH dataset where the model predicted positive for a pathology. 50% were selected because they were false positive predictions. Each image was viewed in the two ways shown here, using either traditional methods or counterfactuals. Let's take a look at an example prediction and try to use the different methods to verify if it's correct. The model predicts 61% that the patient has a mass. The traditional image gradient highlights an area next to the esophagus. In the counterfactual animation, we see the mass is clearly highlighted. This looks like a true positive. Let's take a look at another positive prediction of mass. The traditional input gradient doesn't give a clear indication. The counterfactual shows that it's focusing on a port in the patient. The network seems confused. This looks like a false positive. Here we see histograms for the 6 pathologies evaluated. We would like to see that for true positive, the results are all 5, and for false positives, the results are all 1. What we observe, however, is that many false positives still cause high overconfidence in the model predictions, but not as much as the true positives. Between the two methods, we find that for true positives, the counterfactuals show a significant increase in confidence, which is good. These results demonstrate that showing counterfactuals can have an impact on the user confidence in the model.